All right, guys, welcome to this page of the notes. And what we've got here is one last thing, objective we've got to kind of get through before we can really sort of start working on problems. And again, it's something that it's just another version of something that we have already seen. In the previous section, we talked about the segment addition postulate, and on the previous page of these notes, we saw the angle addition postulate, right? So a relationship between line segments and angles. Well, here we see another one. In the previous section, we talked about a segment bisector, right? And what we said is a segment bisector will divide a segment in half. So you get two congruent segments, right? It splits it right down the middle through the midpoint. Well, here we see angle bisector, right? Yet another correlation, a relationship between line segments and angles. And if you remember our essential question, we asked, what do angles have in common with line segments and how are they different? How are they the same? How are they different? So we're working our way through so that you can answer that question. All right, so here we go. An angle bisector, and after talking about line bisectors or segment bisectors, this shouldn't be too difficult. What you're going to do is if you have an angle ACB, angle ACB, if the ray CP is an angle bisector, it will split that angle right down the middle, and you should recognize the notation. Please notice that this angle has a hash mark through it, this angle has a hash mark through it, and those dashes tell you the angles are congruent. They're the same measure and the same shape as each other. And you know that because we tell you that it is an angle bisector. Right? Bisects the angle in half. So you have two congruent, smaller angles, all right? So we'll use that quite a bit here when we get down to, you guys have seen this before in geometry, right? You're gonna be given a diagram or a description, right? And you'll need that piece of information, angle bisector, to help you set up the problem that will allow you to reach your solution, okay? Just like we did in the previous section. A couple other things here that we want to go through, just some other angle relationships. Not that they're less important, they are very important, but I can really only say them one time. It's kind of up to you to get the practice, to get good at knowing how to use them. And we do have some example problems here in just a second. Again, hopefully something that you are already familiar with. If not, here it is. Complementary angles. Complementary angles will sum to 90 degrees, right? Complementary angles are two angles that when you add them together equal 90 degrees, or a right angle, right? They make a right angle. And then this one right down here, supplementary angles. Well, as you can see from the diagram, these will sum to 180 degrees. So complementary, two angles that sum to 90. Supplementary angles, two angles that sum to 180 degrees. Very, very important. Please make sure that you get that, remember that, we'll practice. Then, just as important, adjacent angles. We use that term adjacent in the last section. Remember, adjacent simply means next to each other, next to each other. So if you have adjacent angles, these are going to be angles that are next to each other. Both complementary and supplementary angles are adjacent angles. I have the angle alpha and the angle beta. They're right next to each other. They share, ready for this? Adjacent angles. In fact, I think does it say it over here? Yes. Oh, I'm not even gonna bother writing it. I've got it right here. Angles with a common vertex and a common ray, all right? It's an adjacent angle if they share a vertex and have a common side or a common ray, all right? And both complementary and supplementary angles are adjacent angles, right? They share the common vertex and they share a common side, all right? That is not the case for vertical angles, but vertical angles are just as important. In fact, vertical angles are very, very important. We will be looking at vertical angles, using vertical angles throughout the rest of geometry. In almost every single chapter, we're going to do something with vertical angles. It just keeps coming up and up and up. So here we go. Vertical angles, please notice, not adjacent. Not adjacent. Take a look at this. Yes, they share a common vertex. Right there, share a common vertex. but they do not share a common side. They do not share a common ray. So they are not adjacent. However, something awesome about vertical angles and why I think you can probably figure out why they're going to come up quite a bit is if you take a look at this, please notice that if you have vertical angles, the measure of the angles are congruent. Put a little hash in there, right? The measure of that angle is congruent to the measure of the vertical angle. They're going to be the same measure. So, all I have to say to you, angle A and angle B are vertical angles. You immediately know, oh, they have the same measure. They're equal to each other, all right? So here we go. Let's go ahead and try some of these guys and let's see what we can get going here. Okay, so what I've got for you guys here is I've got a couple of problems. Let's see, we're going to, in this first one, I want you to, the measure of ACB is 50. The measure of ACE is 110. I want you to find BCE. Okay, here we go. So we're going to go ACE. That's my biggest one, so we're going to go A. C is the middle letter, the middle point, so that tells me it's the vertex, A, C, E. Okay, out there. So here's my... Oh, I missed it. There we go. All right, and we're given that measure. We're given it right there. It measures 110. All right, so there's ACE. Then I'm given ACB, which is 50. It's less than 110. It's somewhere in there. So let's go ahead and do that one. Let me go ahead and put B, I don't know, let's say right there. That looks like a good spot for B. We'll draw that guy right there. And I'm told that that guy is, boom, 50, right? Okay, what do they ask you to find? Well, it's, hopefully right away you recognize this is the angle addition postulate. Please notice that I have the angle ACB and the angle BCE, and those two angles are adjacent angles that make up the angle ACE, the larger angle. Well, I've been given two of them. You're asked to find the third. Okay, awesome. Here we go. The angle addition postulate, I apologize, I'm running out of space up there. Let me do it down here. If I do the measure of angle ACB plus the measure of angle BCE, right? So that's ACB plus BCE. What is that equal to? That's equal to the larger angle, equal to the measure of angle ACE, right? That bigger angle, all right? So this is the angle addition postulate. Now, plug in what you know, right? Well, I already know ACB. ACB is 50. Plus, I don't know, that's what I'm being asked to find. Equal to, well, the measure of angle ACE, I'm already told, it's 110. So how do I find the measure of angle BCE? Very, very simple algebra problem. Subtract the 50 to the other side and you wind up, of course, with 60. Since that's what I was asked to find, that is my final solution, my final answer. And again, guys, this description, you needed to know a couple of things. You needed to know the angle addition postulate in order to set the problem up to then use algebra to get to your solution. Okay, see how geometry is taking us one step beyond what we got in algebra, right? This is the algebra, but to get to that algebra, right, you needed to know something about geometry. You needed to know that angle addition postulate in order to help you work your way through the problem. All right, that's just the way that geometry is going to work. Draw angles that satisfy the following conditions. Sweet, let's do this. Let me get rid of that guy so it's not in my way. Here we go. Okay, two angles that intersect at one point. There's several ways to do this, several ways to draw it, so my drawing is not the only one, but I certainly could. Here's my point. I need two angles that intersect at that point. You could, if you wanted to, draw two angles like this. There's one. There's two. Angle, angle. Now hopefully you recognize these as vertical angles, which tells you that those two angles have to be congruent. That is not the only way that you could have done this. You also could have done it. And there is my common point. I have two angles, that one, and they intersect at a common point. All right, so both of those, as far as what I gave you, both of those are perfectly okay. They both work. They both satisfy the description that you've been given. Measure DEB plus BEF, DEF. All right, awesome. Here we go. So let's do this. E has to be my vertex. Let me start there. There's E. I have DEB and then BEF. All right, so D, B, F, D, B, F, right? I am told that DEB plus BEF, right, is equal to DEF, right? Do you see that, right? I've got DEB plus BEF is equal to DEF, right? That overall larger angle. This is the angle addition postulate, just describing that, or this is the figure representing that picture. And then this one, really, really easy. B is your middle point. I've got two rays. I've got ray AB. Let's put A over here. Let's put C over here. I know that they're opposite rays. They have to go in opposite directions. They're two rays that form a straight line when you put them end to end. All right? Two rays that form a straight line when you put them end to end. All right, guys, head on over to the next page of the notes. I got a couple more for you here just to kind of finish this up, really make sure that we are getting lots of practice with sort of all the things that we've looked at here with angles. And as we practice, right, hopefully what we're doing is taking those objectives, those tasks that we learned and really sort of helping us solidify those things. Also, remember the way this works, please, once you feel comfortable with something, work ahead, see what you get. Come on back and check your answers with me. So if you're coming back after doing this problem, let's see how you did. I have ray BA and ray AE, opposite rays. Ray BC bisects ABD. All right, here we go. So we're going to draw a picture of this. First, this part, ray AB and ray BE. These are opposite rays where B is the common part. So here's B. I'm going to have A, and I'm going to have E. Got it? Opposite rays. Okay, so that takes care of that first part. Ray BA, ray BE, opposite rays. Now, here we go. Ray, it's a ray, BC. So it starts at B and runs through some point C. We'll figure out where that's at. Ray BC bisects ABD. Okay, so I need to create another angle, AB. I need another point D. Does it tell me where to put it? Nope. Okay, so let's find a point D. Let's say right there. Doesn't tell me where to put it, so I'm going to put it right there. That's what we'll call it. And hey, I'll go ahead and throw that guy in there because why not? It's a right angle, right? I want it to be a right angle. They didn't tell me to make it a right angle, but since they didn't tell me and they didn't specify anything else, work smarter, not harder. Right angles are easy, so we do a right angle. But here's what they want. They want this ray BC, which I haven't drawn yet, I'm going to draw. They want that ray BC to bisect ABD. So this angle right here, this right angle, I need to split it right down the middle, right? That's what bisect means. Split it into two congruent parts. Okay, well what that means is I need point C, let's say right about there, looks like a bisector. run that guy out through there, and here's what I know. This guy and this guy are congruent angles. Ray BC is an angle bisector. Splits it right down the middle. How does that work? Well, since I drew this as a 90-degree angle, where's that telling you? 45 and 45. Right? 45 plus 45 gets you 90 degrees. Right? So, based on the description that I gave you, this is perfectly okay. Is it the only way to draw it? No. No, it's not. You could have drawn something else and been just fine. In fact, absolutely correct. Based on the information that you were given, this was just the way that I happened to do it. Here we go. The measure of ABC. A, B, C. Fantastic. I'm given ABC. Great. Measure of CBA. C, B, D. Look at that. Awesome. Do you see that? So I've got this smaller angle, ABC, and CBD. Guess what's probably coming? Angle addition postulate. I want you to find CBD. Okay, so here we go. Well, since, right, I know ABC and CBD, right, are congruent angles, I know that because BC is an angle bisector. These two angles have to be the same, so set them equal to each other. I know that the angle ABC is congruent to the measure CBD, right? So here we go. I have 4x plus 1 is equal to 6x minus 15. Right? Let's do a little bit of algebra. Subtract the 4x, that's going to give me 2x. Add the 15, that's going to give me 16x is equal, divide the 2, you wind up with 8. Did I ask you to solve for x? No. We've seen this over and over and over again. Please be very, very careful not to get algebra brain, right? Algebra brain said, oh, I solved for x, that's my answer. Careful. This is geometry. Please be very, very careful. I asked you to find the measure of CBD. So the measure of CBD is equal to 6x. Oh, sorry, I don't want to do that. I'm squeezing, and I hate squeezing. I don't want to squeeze. The measure of CBD is equal to 6x minus 15, but I know what x is. So that whole thing is equal to 6 times 8 minus 15. Plug and chug if you have to. Don't fat finger something on your calculator, and you should get that the measure of CBD is 33. All right. So there we go. Fantastic problem, and you needed to know something about angle bisectors, right? You needed to know what that means, that BC, ray BC bisects this angle DBA right down the middle so that those two pieces are congruent. That way you can set up your algebra problem, which is setting them equal to each other, solving for x. But then once you know x, don't forget that last step. Actually give me what I ask you for. Hey, let's keep going, but real careful in this one. I apologize. I'm going to use the exact same diagram. So sorry though. I do have a typo in here. Simply change this to the measure of DBC. So go ahead and squiggle that out, right? Not the measure of DEC, not that, right? DEC doesn't make any sense, my fault, typo. DBC, so DBC, right? So I want you to find that measure. Actually, I don't want you to find it. I tell you what that is. And then I give you ABD, BD, fantastic. I give you A, B, D. I want you to find A, B, C. Okay. Looks like another segment addition or angle addition postulate. So let's go ahead and set this up. Here's what I know. I know that the measure of angle A, B, C plus the measure of angle C, B, D is equal to the measure of angle D, B, A. Right? So I know that this angle plus this angle is equal to D, B, A, the measure of the larger angle. Okay, but what have I been given? Well, I've been given the measure of DBC, which is that smaller angle, and I've been given the measure of ABD, which is the larger angle, right? So I don't quite yet have enough to plug into this. We'll come back to that in just a second. Here's what I know. I've been given, right, DBC, and because BC is a bisector, if I multiply DBC by 2, right, take that angle and multiply by 2, I get the full angle. So I am actually going to start off with this. I need to do this first. I need to do the measure of angle DBA is equal to 2 times the measure of DBC. All right. Now I can plug stuff in. I know DBA, DBA, I wrote it in the reverse order, but again, remember that doesn't matter. So it's 22n minus 11 is equal to 2 times DBC. So 12n minus 8. All right, here we go. Let's solve for n. Distribute the 2. So 24n minus 16 equal to 22n minus 11. Let's subtract the 22. That'll leave you with 2n. We'll add the 16, which will leave you with 5, and we wind up with n is equal to 5 over 2. Okay, fractions are going to happen. Please be comfortable with dealing with fractions. It's going to happen. We're going to use them. Fractions are friends. 5 over 2, it's going to happen. We're going to use it. Now that I know what n is, right? Well, let's answer our question. A, B, C. Well, come back up to our diagram, right? Take a look at this. I want to find A, B, C. Well, I know that the angle ABC is congruent to DBC, which I already know, DBC. So here's what we've got. I've got the measure of angle DBC is congruent to the measure of angle ABC, which is the one that I want. And I'm told what it is. It's 12n minus 8 has to be congruent to the measure of the angle that I'm looking for. Right? But I already found n, right? Remember, it's right down here. 5 over 2. Sorry, 5 over 2. There is no over. 5 divided by 2, or 5 halves, right? 5 halves. So we'll plug 5 halves in for n. We have 12. 5 halves minus 8. Okay. Here we go. Couple of ways that you can do this. 12 times 5, then divide by 2. Also perfectly okay. 12 divided by 2, then multiply by 5. 12 divided by 2 is 6. 6 times 5 would be 30, right? 30 minus 8, 22. So we get 22 is the measure of angle ABC, which is what I asked you to find. And again, be comfortable with fractions. I can either multiply the 12 into the numerator, 12 times 5, and then divide by 2, subtract 8. Perfectly okay to also 12 divided by 2, which is 6, then multiply that by the numerator, which is 5, then subtract 8. Both of those are okay. Whichever way makes you the most comfortable is the way that you should do it. And that was the answer that we were looking for. Hey guys, that concludes this set of notes and this section of videos. Thank you so much for joining me. I really had a great time going over angles, how we measure them, some of the relationships that we see in angles. Again, please pause, rewind, stop, and go over this video as many times as you need to be comfortable with both the language of geometry and, given a problem, how we can use the definitions, postulates, and theorems to set up a problem we can then use to reach our solution. Once again, thank you so much for joining me. I'll see you guys next time.